like this. Now wait a minute, let me touch this. These are touching each other.
Okay.
And then other atoms like this. So if I'm going to ask you the coordination number of this atom, so this atom will have coordination number, that is 4, because it is directly in contact with this atom, this atom, this atom, this atom.
Oh, okay. Yeah.
So this is coordination number, and this coordination number generally depends upon the size. If you have a very small atoms or a ball which will be connected with very less number of atoms, that is directly connecting with each other, contacting with each other. But if you have large type of atoms or balls, you will have large number of atoms that will be touching each other, right? Yes or no?
Yeah.
So basically this coordination number is depends upon size. So before
Okay.
starting this radius ratio, I just explained what is coordination number. Now come to the point, radius ratio.
Okay.
So what is the definition of a radius ratio? First, we are going to see this radius ratio. So basically, a radius, like as you know that NaCl exists in 3D form,
Okay.
that we study about it's cubic in nature. Okay, the unit cell in NaCl is cubic. So
Okay.
basically, you can see Na plus and Cl minus. That means basically there is cation and an anion. So we are
Yeah.
going to talk about the radius ratio, and radius ratio is basically the radius of cation upon radius of anion. So how
Okay.
we are going to define this radius ratio? RR is basically radius of cation upon radius of anion. This is radius ratio.
Okay.
Now another term, that is another concept that is very important. If I'm going to ask you a simple question, that is, if you have any atom like M, and I'm going to write M plus and any element and M minus. That means basically a neutral element, and then it is a cation. That means we just take out an electron, and an anion. That means we added an electron. So my
Yes.
question is very simple about its size. Which one will be the largest and which one will be the smallest? You are going to arrange it in increasing or decreasing order of their size. So the question is
Okay.
simple. Yes.
So increasing would be order would be M plus M, then M minus.
Very good. You want to say this, right?
Yeah. Yes.
It's very simple to understand. So basically, you can understand that generally a cation is smaller than an anion, or you can say
Yes.
anion is bigger than cation.
Yes.
Now come to the point. Neutral is in between cation and anion. You know that. Now
Yeah.
I just defined the coordination number. Coordination number. That means nearest neighbor. Nearest neighbor atom, or we can call it nearest touching atom. Nearest touching atom. This is coordination.
Okay.
So here we are going to learn about a cation is surrounded by how many anions? How many anions? If cation is
Okay.
larger, that means the anions surrounding that cation will be larger in number. And you have
Okay.
studied about potential energy in electrostatic, right? Physics.
Oh yes. Yeah.
Yes. So basically, if you have a radius of cation, you are going to increase. That means if you have radius of cation increasing, that means coordination number increases.
Yeah. Okay.
Yeah, that's simple. Like if you have a cation like this and you have a cation like this, so this will have higher coordination number as compared to
Yes.
this, And whenever the coordination number is high, that means if a cation is surrounded by a large number of anion, that means the potential energy, basically the potential energy is very low. And when energy is low, that means stability increases. Stability increases.
Okay.
So basically, the new concept or the modern concept of stability is based upon energy. Energy is inversely proportional to stability. If you have a compound which has 10 joule energy, and if I have a compound which has 100 joule energy, so the stable compound is the one with you, which has 10 joule energy, because
Okay.
stability is inversely proportional to energy.
Okay.
So the question can be asked like, if a cation is uh, a cation is C1 and C2, which is bigger, this is bigger in size. So which one will be more stable? So this one will be more stable because this has bigger sizes. That means it is surrounded by larger number of coordinates, larger number of anions, which reduces its potential energy. That means its stability increases.
Okay.
Clear?
Okay. Yeah.
Okay.
Yeah.
So it's very simple. Now, there are three assumptions in this potential energy assumptions, which you need to keep it in mind. So basically, we study here about the number of anions and cations surrounded. So the
Yeah.
first point, which is important, cation and anion are assumed to be spherical, that we take from childhood, assumed to be spherical instead, spherical, and touching each other. Since they are opposite in charge, they can touch each other, touching
Okay.
each other.
I mean,
The next point,
all atoms are spherical, right?
yes, that
Okay.
is that's why I told you from childhood,
Okay. Yeah.
right? There is no new concept in this. Now the
Okay.
next point is basically an ion will not touch other anion. Since a cation is surrounded by an ion, that there might be possibility of touching each other of an ion, but the assumption is they cannot be touch each other because there will be repulsion between them. Just like
Oh, okay.
this is our cation, this is our cation, and if you have an ion like this, they can touch each other, but they will I will show you, basically they will touch each other, but they cannot be touching each other. Are you getting my point?
Yeah. Yeah. Yes.
My drawing is not that much perfect. Now the third
Uh,
point, cation surrounded must be surrounded by maximum number of anions. If it is satisfying this and this, and it has maximum number of anions, that means that is stable. So that's why I wrote here, cation must be surrounded by maximum number of anion that is possible. Okay,
okay.
but they cannot touch each other. Anion and anion cannot touch each other.
Okay.
Now, can I move to the next part?
Yeah. Yeah. Please, I think. Yeah.
Okay. Now see, if we have a cation like this, there will be three anion that is surrounded. Surround this. This is about to touch each other, but they are not touching each other. There is simple maths which is very easy. Now
Okay.
see, this cation will have a diameter and a radius that I am going to take a small r. Okay, and I'm going to make a triangle like this. So there will be equilateral triangle. The
Okay.
triangle is equilateral triangle, and now
Okay.
I'm going to make this. Now this hypotenuse, you are seeing the small triangle. This hypotenuse will be r plus r, the radius of anion plus radius of cation.
Yes. Yes. Yeah.
And you can see, since this is a equilateral triangle, so I just draw a line, so that this line will be bisecting each other, this angle, and it will be 30 degrees.
Okay. Yeah.
So I'm going to apply cos 30 degrees. So as you know that cos 30 degree, cos that means base upon hypotenuse, which has
Yes.
a value base. Base that means this will be the base. So base is radius of an ion upon the hypotenuse is the sum of radius of an ion and cation r plus r. Is that clear?
Okay. Okay.
Now
Okay.
this
Yeah.
cos 30 degree will have a value root 3 by 2, and we are going to solve it r plus
Okay.
r. And we are going to solve it in the way we are going to solve the value of, we are going to get the value of radius of cation and radius of anion, and then we are going to write the range of that. So I'm going to multiply it. Cross multiplication will be there, so it will be like this, and then there will be 2r. Now you can see
Okay.
uh, I did it correctly. Okay, so I'm going to move it to the right hand side, so it will be 2r minus root 3r, and there will be minus root 3 small r, and r I am going to take common. 2 minus root 3. Root 3 has a value, can you tell me? 1.73, right?
1.732.
Yes, so it will have a value. Root 3r will be r into 2 minus 1.2 minus 1.73, and I'm going to write r upon r, and 2 minus 1.73, how much it is? 0.27. And since
Yes.
this is in multiplication form, it will be in denominator of the right hand side, and if you are
Yes.
going to solve it, you will get 0.155. But in turns, we are not going to do this, but we need to remember the value, the radius range, the radius ratio range. And here you can see, since this cation is surrounded by 3 atoms of an ion, this is called triangular. This is called triangular.
Triangle.
If a cation is surrounded by 2 atoms, that will be known as linear, and this is triangular. If a cation is surrounded by 4 anions, that is tetrahedral. If a cation is surrounded by 6 anions, that is octahedral. And if a cation is surrounded by 8 anions, that is BCC, body centered. And if a cation is surrounded by
Oh.
12 anions, I'm going to write it all, I'm just telling you, then it is
Okay. Okay.
CCP, cubic close package. So first you are going to write it, and then I'm going to write the name as well as the radius range, radius ratio
Okay.
range. Okay. Just let me know when you finished with this.
Yeah.
Yes, sir.
Uh.
Wait a minute. I
Okay.
just
Okay.
yes.
Yeah.
So have you solved questions?
No. No. Yeah. That PYQ, right? I didn't like. Where am I supposed to get it? From my that Learnivio website or
No,
like
no,
from
no, no, no.
WhatsApp?
I'm just sending in the coaching, then you will get it from there.
Yeah, that's why I didn't get it anywhere.
Okay,
I had to
okay,
check. Okay.
okay. Basically, I'm going to send 2 PDFs.
Okay.
One will be easy, so I will recommend that to for
Okay.
solving it first.
Okay. Fine.
Done.
Yeah, we are finished. Yes.
Okay, okay, wait a minute. I'm going to send it first, and then
Okay.
NTA. You will get it in a few minutes.
Okay.
Now let's start. Okay. Anion to cation ratio. This is anion to cation. Now the first is basically, as I told you, linear. That is surrounded by two atoms. First, I'm going to make it heading anion to cation, coordination number, nearest touching atom, and then RR, that means radius ratio range.
Okay.
So you know that linear is has a coordination number 2, and it will have a radius ratio range that is from 0 to less than 0.155. Then triangular comes. Triangular will have a coordination number 3, and its radius ratio start from here. It can be equal to 0.155, but lesser than 0.225.
Okay.
Now, after triangular, there will be tetrahedral. That means its coordination number will be 4, and its radius ratio, it can be equal to 0.225, but lesser than 0.414. Then octahedral. Octahedral's coordination number will be 6, and its radius ratio will be equal to or less than greater than 0.414, but lesser than 0.732. And then BCC comes. 8 spheres. Basically, here 8 spheres are there, BCC, and here the coordination number is 8, and its radius ratio will be greater than or equal to 0.732 and lesser than 0.1. Wait, lesser than 1.
Okay.
And then cubic close packing comes. Close packing. That is basically CCP, cubic close packing, and HCP, hexagonal close packing. CP for close packing, and H for hexagonal, C for cubic, and its coordination number is 12, and its radius ratio is.
Oh, always exactly 1.
Yeah.
Okay.
Lesser than greater, not greater than, it will be 1.
Okay. Wait, is it
Please let me know
possible
when you are done.
for radius ratio to be 0, like in linear?
Linear, just remove, no,
Okay.
not 0. It will be very, very less.
Yeah.
Or basically, we sometimes we just neglect it in that case only.
Okay.
Are you done with this?
Wait, last 1 minute.
Please write it. Okay,
Yeah.
take your time.
Yeah, finish.
Okay, there are some questions that is very important to do. That is basically the question is a cubic solid. We need to do different types of question
Okay.
made of 2 elements P and Q. Atoms of Q are at corners. Atoms of Q are at corners of the Q, and P at the body. Body center. What is the formula of the? What is the formula of the compound?
Will it be like PQ8 or something?
See, I'm going to
Okay.
explain it. Might be you're seeing it first time. P
Yeah.
is Q is at center. So due to Q, number of
Wait, Q is
atoms
at
will be.
corner, right?
Oh yes, sorry.
Yeah.
Q is
Okay.
at corners. So due to
Okay.
Q, the number of atoms will be present will be one, right?
Oh, okay. Yes. Yes. Okay.
And for P, since it is present in the body center, due to this, the number of atoms is also one, right?
One. Yes.
So if I'm going to tell you that there is sodium and there is oxygen and its number is 2 and its number is 1, so what will be the formula? The formula will be Na2O. So in the same way, the
Yeah.
ratio is, you can see the ratio here 2 is to 1. Here you can see the ratio is 1 is to 1. So the formula will be PQ.
Okay. Okay. Yeah.
So from this information, we just calculate the number of atoms first. And if you are going to calculate the number of atoms first, then you can easily make a formula out of this. Okay.
Yes. Okay.
So I'm going to give you another question on this, which is very
Okay.
easy.
Yeah.
And I think you can do it easy.
Okay.
A solid is formed by crystallization of X and Y elements. If X occupies corners of Q and Y occupies face center of Q, then find molecular formula. I think you got the book. If you will check WhatsApp.
Okay. Okay. Wait. One. I'll solve and then.
Okay.
Yeah. The molecular formula is XY3.
XY
3.
3. Wait a minute.
Okay. Yeah, I got it. Yes, I got the PDF. Yes, I got
Okay.
it.
Thank you. Okay. So the formula is XY3, right? It's
Yeah.
very easy.
Yes.
There is another type of question that comes from class 11. How's your class 11? And there is
Um.
more maths than chemistry. Yes. In this question, the
Okay.
maths is more than the chemistry.
Yes. Okay.
How's your 11th now? You can tell me.
How is my 11th? As in,
Yes,
like,
chemistry. How's your chemistry of class 11th?
okay. Yeah. Uh. Yeah. Pretty good. Only like,
Pretty.
yeah. It's good. It's good. Yeah.
It's
I
good.
think only
Okay, okay.
one or two chapters. It's slightly good, but
Okay,
other than that, mostly good. Yeah. Chemistry of class 11.
okay. Please do it. If you don't have any idea, you can take hint from me.
Yeah. 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 No idea. No.
Okay, that's good.
Sir is not audible.
Yeah.
Okay.
Yes, I'm here. Should I explain?
No, I didn't get. Didn't get. I forgot. Hmm.
Uh, should I start explaining? You did. You don't get what?
No, yeah, this question's answer I'm not getting.
Okay. Okay. See,
Yeah.
it's very simple. Analysis shows that NiO, nickel
Hmm.
oxide, has the formula this. Okay, and
Okay.
it is saying that calculate the fraction of Ni plus 2 and Ni plus 3. Do you know this? And nickel is from D block element. It's D block element, right?
Yeah. Yes. B block. Yeah.
And you know that D block has a variable valency, like
Variable valency. Yeah.
manganese exists in plus 2 plus 3 plus 4 plus 5.
Yes.
Nickel
Yeah.
exists
Yeah.
as Na plus 2 Na
Yeah.
plus 3. Copper exists as plus 1 plus 2. So this
Yes.
D block has variable oxidation state. Now
Hmm.
this is the formula, and in this nickel is 0.98, and in this nickel exists as Ni plus 2 as well as Ni plus 3. Okay,
Yeah.
there is some of this. So I'm going to basically I just wrote it wrong. This is the form. This is the formula is basically Ni 0.98. So I'm just
Okay.
going to multiply it by 100 in both, so it will be Ni 98 and 100. It will be yes or no.
Yes.
Now see, it's very simple. In this compound, total number of nickel is 98, and nickel has two form double face. It is Ni plus 2 as well as Ni plus 3.
Yeah.
Now I am going to take the number of Ni which exists as Ni plus 2 as B. Let's say it is X. So what will be the number of Ni plus 3? Can I write it 98 minus X?
Yes. Yeah.
So it's very simple. Now see, this is Ni 98 O100. So I'm just going to apply the formula for basic, like you know oxidation state. So
Okay.
nickel plus Ni plus 2 X I just took, and Ni plus 3 as 98 minus X. So I'm going to apply the
Yeah.
formula for oxidation state. What is the oxidation state of this nickel? Plus 2.
Yeah.
And
Plus.
what is the number of nickel existing as plus 2 X? Yes or no?
Oh, okay. Yeah.
See, it's very
Yes.
simple. Plus, now nickel existing as plus 3 has a
Plus.
number 98 minus X. And what is the oxidation state?
Plus
Plus 3.
3. Yeah.
Now, plus. What is the number of oxygen? 100. And the oxidation state of oxygen is
Minus 2.
minus 2. And overall charge is 0 equals to 0. Can I write it?
Yes. Yeah.
Now, it's very simple. 2x plus 3 into 98. That means 3 8 is 24. 3 9 is 27. 2 90. 29 to 94. Minus
Yeah.
3x and minus 200. Now see, it's very simple. Your maths, minus 3x plus 2x minus x, moving to
Okay.
right hand side, it will be x, right?
Yes.
And now
Yeah.
plus 294 and minus
94.
200, that is 94. That means basically the number of nickel existing as plus 2 will be equal to 94. So the fraction will be the number of Ni plus 2 upon total, that is 98. So can you tell
Okay.
me the number of Ni plus 3? And 98
4.
minus x, that is 94. That will be 4.
4.
So the fraction will be 4 by
4 by
98.
98. Yes.
And if the question will be calculate the percentage, what you just need to do, multiply it by 100 and
100.
multiply it by 100, you will get the percentage.
Okay.
So please write it and then let me know.
Okay.
So we studied about the packing efficiency. Now we are going to study about the packing. First, we are going to write it, and then we will talk.
Yeah. Yeah. Finished also.
Okay. Now come to the next topic, which is very interesting. So I think it's a very interesting topic. Just suppose you are going on a trip and you have bought a bag in which you are going to fill it with your gadgets and clothes and everything.
Okay.
So if you are going to just fill the bags like not folded cloths, you can see the your gadgets and the things that will be occupying the place in your bag will be very lesser. That means
Okay.
basically I will again explain what I want to say is first I'm going to write bag. So you are going on a trip, and if you are going to fill the bag with folded clothes, the number of clothes will be increased as in compared to you are just going to take the clothes and just keep it in the bag. Are you
Yeah, yeah.
getting my point?
Yes, yes,
So in
yeah.
that case, you can see in that case the efficiency of bag will be decreased in comparison to the folded clothes
Yes,
in a
yes.
arranged way. So this packing is just like that. So this packing will be divided into three parts: 1D, 2D, and 3D. So first of all, I'm going to talk about in 1D, one dimensional. One dimensional, you know that either we can take X, Y, or Z, right? So I'm going to take X. So you
Okay.
have balls. So you can see this will be arranged in on x-axis. So you can see
Yes.
this is 1D, one dimension. So can you
Yeah,
tell
one
me
day.
the coordination number in 1D?
Is it two?
2. Yes, it is 2.
Okay.
You can take any other any atom, its coordination will be 2.
Yeah,
So
two.
it's very easy. Now
Yes.
come to the next, which is in 2D. In two dimensional, we have two parts. One is basically a square packing, and the another is 2D hexagonal packing. This 2D
Okay.
has two parts. The first one is a square packing. You will see the difference. 2D square packing, and the next is 2D hexagonal packing. And you know that if I'm going to talk about 2D, that means two dimensional will be there, X or Y or Z, X or Z, whatever you are
Okay.
comfortable with. So this is in 2D. So can I change the slide?
Wait 1 minute.
Yes, yes, just write it. First, you are going to write it, then we will move.
Yeah, done. Okay, done.
Okay. So see, in a square packing, it's in 2D square packing, it's very easy to understand. This is 2D square packing. And I'm going to take X or Y as it is very familiar with us.
Yes.
This is X, this is Y, and this is X. To show you it is in 2D, you know that. So what is
Yeah.
in 2D? 2D square packing. 2D square packing. So basically,
Okay.
there are atoms or balls like this, spherical balls, like you can see. The next step, this is in 1D. Now, going to
Yeah.
make it 2D. That means the next atom will be just kept below this. The next
Okay.
atom below this, then this. That means basically a layers are same. Layers are same.
Yes.
You can
Yeah.
see the layers are same. Now, can you tell me the coordination number in this? You can take this 1, 2, 3,
Three,
4.
four. Yeah.
So the coordination number will be 4.
Four.
Are you getting my
Okay.
point?
Yeah. Yeah. Yeah.
Now see, if you have 2D hexagonal packing, if you have 2D hexagonal packing, there will be two types of layer. There will be two types of layer. And in the first layer, you can see this is the first layer I'm going to make. 3, 4, 5, and then 6. The first layer is like this, and the second layer is in between these two, in between these two, in between
Okay.
these two, in between these two, in between these two, and in between these two. And the
Okay.
third layer again as the first layer. The third layer again as
Oh,
the first layer. And the fourth layer again as the second layer.
second
The
layer.
fourth
Okay.
layer again as the second layer in between these two, in between these two, in between these two, like this.
Okay.
Now Can you tell me the coordination number in 2D hexagonal packing?
Is it 6?
Yes, it is
Okay.
6. It's very easy to understand. You can
Yeah.
see, just make a square hexagon. Wait
Yeah.
a minute. It will be like this.
Yeah. Oh yeah. Also, shape is like an hexagon. Yeah.
Yeah, it will be hexagon. This is also touching this. So one
Yes.
atom will be touching with 6 other atoms. So this is
Okay.
2D hexagonal pack. This is in 3D. It's this chapter is very easy. Your
Yeah.
imagination power in this is good. Very good.
Yes.
Please do it.
Yeah. Yeah. Done.
Done. Now we will go for the third type of packing, that is basically in 3D.
Okay.
And in 3D we have 3 types of packing. The first one is AAA type. AAA type. The 2D square packing is same as AA type packing. Only the difference is that it is in 3D, that is in 2D. Are you
Okay.
getting my point?
Okay.
And
Yeah.
the
Yeah.
next is AB type. AB type. It is similar to that one. And the third one
Okay.
is ABC type. You will see the difference in this, which is very easy. So
Okay.
just write the topic, then I will explain one by one. Then there will be voids, which is very important.
Yeah. Done. Okay.
Done. Very good. So I'm going to take first AB type. AA type. A
Hmm.
A A A type, like this. So it's very easy. It's very easy. You can see if you have this, you have this, this. These are all equal, and the
Yeah.
next layer will be same as the first layer.
Same. Okay.
Now the next layer will be also the same as third layer will be. Every layers will be same. Are you getting my point?
Okay. Same. Everything same.
Every layers are same. Now see the difference. Basically, is it in 2D or 3D?
This
This
is
is in
2D.
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 Now, if I'm going in 2D, what we have length and breadth, but in
Yes.
3D we have
Height.
height also. So
Yes.
basically, with each atom, there will be an atom at bottom and at top also, right? Are
Okay.
you
Yes.
getting my point?
Yes.
This
Yes.
is length and breadth, and for
Yeah.
height, there will be atom on top and
Bottom.
bottom also. So this is A type A type pack. Now, can you tell me the coordination number for A type?
Uh, is it uh, is it 6?
Yes, it is 6. Very
Okay.
good. Very
Yeah.
good. You can see 1, 2, 3,
2, 3,
4.
4. Yeah.
One bottom, one
One
top.
top.
The
Yeah. Will be
coordination
6.
number will be 6. It's
6.
very
Okay.
easy,
Yeah.
right? Very good.
Yeah. Yeah.
Can I move to the next part?
Wait. 1 second. 1 second.
Please, yes. Please write it.
Yeah. Okay. Done.
Okay. Now see, there is some important concept that we should know. So you know that this is an atom, this is also an atom, and this is also an atom. So if you are going to take a spherical balls of the same size shape or same size, and you are going to make it close to each other, so there will be a void left. If you are going to make it close, there will be some spaces left
Yes.
between them. Yes or no? So if
Yeah.
this is space made by 3 spherical atoms, this is known as triangular voids. Triangular
Void.
voids.
Okay.
Are you getting my point?
Yeah. Yeah.
Now, if the voids made by 4 other atoms, that is known as tetrahedral voids.
Okay. Yes.
So these are similar. Basically, if you have this ball, and this ball, so you know that there will be a voids, but I want to, since it is in 3D, there will be ball bottom of this like this.
Okay. Okay. Okay.
In between, these 3 balls will be on a single ball that will be in
Yes.
on the bottom of this. So basically,
Yes.
there will be also void that is basically tetrahedral voids. Tetrahedral voids
Right. Okay.
due to 4 atoms, due to 4 spherical
Fine.
balls or atoms. Okay.
Yes.
Now, if you have voids due to 6 atoms, that is known as basically octahedral. Octahedral. Don't go for 8 atoms.
Yeah.
Okay, like you can see, the students generally connect like triangular voids, 3 atoms,
3. Yeah.
tetrahedral voids,
Or
4 atoms, octahedral voids, 8 atoms. No, for
okay.
octahedral voids, it is made by 6
6.
atoms. Like if
Okay.
you know how to make stars from childhood, like this. If you have atoms like this, 1, 2, 3, 4, 5, and if there will be void due to this 6 atoms, that is known as octahedral voids.
Okay. Okay.
Okay, please write it, then we will go for the next one because there will be voids.
Okay. Yeah. Okay. Done.
Done. Very good.
Yes.
Now see, we have another type of void, that is ABAB type, that I already told you that it is like the 2D hexagonal packing. So first of all, I'm going to write it like this: 1, 2, 3, 4, 5, 6. Now you can see the next will be in between these two.
Yeah.
Yes or no? In between these two, in between these two, in between these two. Now the next one, the third layer, will be as
Yeah.
similar to
First
be
one.
the first one. And again, the second, fourth will be similar to the second
Second.
one, right? Now
Yeah.
see, if you are going to read about ABAV type in this, it will not be possible. So I'm going to zoom in. I'm going to zoom it.
Okay.
So I am going to zoom it. You can see this is the first atom. This is the second atom. This is the third atom. And this is the fourth atom. Now the next layer, this, this, and this. And in the third layer, I'm going to take this. I just zoomed it in.
Okay.
Okay. And again, like this. Now, since you know that this is in 3D, this is in 3D, right?
Yes.
So
3D.
there will be atoms in between this. That means basically bottom of these 3. Yes or no?
Yes. Yes.
Bottom of these 3, bottom of these 3, bottom of these 3. So you can
Okay.
see that there is 1 atom, 2 atom, 3 atom, 4 atom, and there is a void. There will be a void. Yes or no?
Yes. Yes.
So this void is known as tetrahedral voids. This is known as tetrahedral voids.
Okay.
This is known as tetrahedral voids. This is known as tetrahedral voids. And again, in the same, this is tetrahedral voids. This is tetrahedral void. So in 3D packing, the A is basically all these layers and B is basically this tetrahedral voids. Are you getting my point?
Oh, okay. Okay. Okay.
In 3D, in 2D packing, the first layer is A, the second layer is B, the third
Yeah.
layer is A, the fourth layer is B. But in 3D
Yeah.
packing, this AB that we were calling in 2D is A, and the second layer is basically this tetrahedral voids.
Okay.
Is that clear?
Yes.
So this is about the tetrahedral. I'm going to write A, B, type. This was the type. A is basically 2D hexagonal, right?
Yeah.
Can I write 2D hexagonal? And B is basically tetrahedral voids. Is that clear?
Yeah. Clear.
And you know what? The coordination number in this is 12. You will think about it today and let me know in the next class how the coordination number of ABAB type in 3D is has a coordination number equals to 12. If you're going to study it from NCRT, you will get a diagram of this and you'll get to know.
Okay. Good.
So please write it off.
Yeah,
Then
yeah,
we will
sure.
go for the next ABC.
Yeah, done.
Very good. Now we will be coming at ABC type. So see again the same thing, again same. What is same? You can see I'm going to again draw that so that it will be very easy to understand.
Okay.
Like this, and in between this, wait a minute. In between
Okay, in
this,
between. Okay.
yeah, in the same as it is.
Yeah.
Like this and this. I'm just going to zoom in and then explain. Okay, you got
Okay.
this?
Yeah,
Now,
this one.
if I'm going to zoom it, wait a minute. Where are you? Yeah. Okay. No, I'm going to make it another. ABT.
Okay.
Okay. So there is an atom, same, and the next in the next layer, in between these two, in between these two, and the third is basically the similar to the first, like this. And you already know that there will be void that is known as tetrahedral, right?
Yeah.
There is a void. Let me do this. There is a void that is known as tetrahedral. There is another void that is known as tetrahedral. This is tetrahedral. Now there will be octahedral voids. Now there is a void. There will be a void between these three that is known as tetrahedral. Yes or no?
Yeah.
Now I talked about octahedral voids. How many atoms forms octahedral voids?
6.
6 atoms.
Yeah.
Now, as you know that these are atoms in a spherical shape, so definitely there will be void. And what type of void? That depends upon the combination of atoms. If it forms between 3, triangular, forms between 4, tetrahedral, and if it forms between 6 atoms, that means basically octahedral. So this you can see this is the atom first, second, third, fourth, fifth, sixth. This is what octahedral voids.
Wait, the tetrahedral void is considered as atom.
Yeah, you can take it as an atom. So because basically it also forms a layer na.
Yeah, okay.
So that's why we just took it as, and this is the octahedral voids. In the same way, if you are going to take this and if you are going to take this, there will be an octahedral voids here, because there is an atom 1, 2, 3, 4, 5, 6, and octahedral voids.
Okay.
So it's very easy.
Yes.
So please write it. Now we will be talking about how many tetrahedral voids present in a cube. and how many octahedral voids present in a cube, and we will take ratio of both of
Okay. Yeah, done.
that. Very good. Now see tetrahedral voids. You just need to remember how many atoms are surrounded in a tetrahedral voids. So for tetrahedral voids, I'm going to use no 3D structure. So this is our square,
Yeah.
and this is our another square. And you can see this. Wait a minute. So this is our square. Now you can see
Yeah.
there is, this is cube, this is cube, this is cube. How many face diagonal present in a cube?
Face diagonal. Six. Yeah.
How many face diagonal present in a cube? Six faces are in a cube, right?
Yeah.
And in one face we will have two diagonal. You
Oh
can
yeah.
see,
Yeah. Two
you can
diagonal. Okay.
see
So
both.
12.
So 12.
Yeah.
Okay. And how many?
Yeah. Yeah.
How many face diagonal? How many body diagonal in a cube?
Yeah. That will be
Just look at your
four.
room.
Two.
Yes, in
Let me
body diagonal, one, two, three,
two.
four.
Four. Yeah.
Right?
Yeah. Four. Yes.
From one side, you will get two, and then one, two, three, four. Yes, four.
Four.
Now see,
Yes. Four.
it's very simple to understand, since tetrahedral words present due to this body diagram. Due to this body diagram.
Yeah.
Only you need to know the concept. What is the concept? Concept is very easy. That made by between four atoms. So I'm going to take this body diagonal out. This is the body diagonal, and as you know that, can you tell me the since one of the edge length is a, so the edge length of this body diagonal will be root 3a. Yes or no?
Yeah.
Now see, there will be an atom at body center. There will be atom at corner. There will be atom on the face. There will be atom on the face. So
Yeah.
due to these four atoms presenting or locating at the corner, face, and body center, there will be a void. Yes or no?
Yes.
There will be void, and that void will be known as, tetrahedral voids.
Yeah. Four. Yeah. Four atoms.
Four atoms, tetrahedral voids.
Yes.
Are you getting my point?
Yeah. Yeah. Yes.
So now you can see from top there will be a tetrahedral voids. Here it will be tetrahedral voids. So I can write this is the body center and this is the tetrahedral. And now you can see from this side, bottom side, there will be an atom. There will be an atom on this face, and there will be an atom in this face, and this body center will have another tetrahedral voids.
Yes.
Yes or no? Now
Yeah.
there is another tetrahedral voids. Now this tetrahedral voids is basically equidistant from this corner atom and from this body center atom. So all and this tetrahedral equidistant from this body center and this corner atom. So if the distance between these two, you can divide it in four. Yes or no?
Yeah. Four. Yes.
So question can be asked in any term, like what is the distance between body center and tetrahedral? It will be basically root 3 by 4. And question can be asked like what is the distance between two tetrahedral voids? on a body diagonal, it will be root 3a by 2.
Okay. Okay.
And it can be asked like, what is the distance between body center and corner atom? It will be root 3a by 2. Yes or no?
Yes.
Question
Yes.
can be asked in any form. So first of all, the distance are clear between any of them. If there will be question, what is the distance between this and that? You can do that.
Yeah.
Now,
Yes.
question arises, how many tetrahedral voids in a cube? Since in a body diagonal, we have 2 tetrahedral voids, and in a cube, we have 4 body diagonals. So total number of tetrahedral voids TV will be equal to 4 into 2, that is 8.
8. Yeah.
Yes or no?
Yes.
It's very simple. Please write
Yeah.
it.
Yeah. Done.
Very good, very good. Now we will come to octahedral voids.
Okay.
Octahedral voids. And you know that due to 6 atoms, right?
Yes.
Now come to the point. First, I am going to make a cube and then another cube. Oh. Then another cube. Why it's not working? Okay, that's good. That's good cube. So this is the cube. Octahedral voids is basically due to 6 atoms. So first octahedral voids is basically due to these 6 faces. So I'm going to write octahedral voids present at body center, and at edge center, So see, now it's very simple. You can see we have 6 faces in a cube. So on the 6 faces there will be atoms. There will be 6 atoms, and due to that 6 atoms there will be voids that will be known as octahedral voids. Yes or no?
Yeah.
So this is clear. Octahedral voids at body center will be equal to 1. This is clear, right?
Yeah.
You need another explanation for this?
No.
If you need, you can see there is an
Okay.
atom, there is an 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 atom, and due to these atoms there will be a void.
Yes.
So that is basically I was talking about the body center.
Yeah.
Okay. Now see. Now see. Edge center. We are talking about edge center, which is very easy. Can you tell me how many edge lengths present in a cube?
12. Yeah. 12.
12.
Yeah.
Okay, if you have an atom at S, in how many parts this atom is divided?
Yeah. It's 4. Yeah. 4. Right? 4.
4. So octahedral voids. Oh, wait, it just abruptly closed. Sometimes it happens with me.
Okay.
So you can see that this octahedral voids at edge center. So these are this is divided into 4 parts. That means 12 S and 1/4 part. That means basically 3 octahedral voids left. Due to this edge center, if you have atom on the edge, it will be divided into 4 parts, and due to this, are you getting my point or not?
Yeah.
See, if you want to go like that, or for octahedral there should be 6 atoms. Where is that 6 atom present? You can easily do that. There is atom, there is atom, there is atom. 3 atoms,
Yeah.
there is atom, 4 atoms. Yes or no?
Yeah.
There will be another cube on this 5th atom.
Oh, okay.
Yes or no?
Yes.
And then 6th atom. You can divide it like that. There is, you can
Okay.
see, there will be another cube. See, how many atoms there is?
Yes.
One, two, one, two, three, four. And there will be another cube, that is 6th atom. Okay.
Okay.
So due to this edge center atom, there will be for one cube, there will be for 1/4 octahedral voids. Due to this edge center, 1/4 octahedral voids, but we have 12 edge length. Due to that, total octahedral will be 3, and octahedral voids in a cube, total number that is octahedral voids is equal to 4. Is that clear?
Okay. Wait, explain that one
So
more
we
time.
can take
One more time.
yes.
Okay.
See, octahedral voids present in a cube is due to two reasons, or at 2 places. The first place is body center, that is one, that is counted, right?
Yeah.
Now come to the edge center. Okay, if I'm telling you this is an octahedral void, this is an octahedral, but it is not a unit octahedral void, not a single. That means if I'm telling you this is octahedral void, body center void, I'm not I'm not saying this. Basically, at this place, we get only 1/4 of the octahedral voids due to one edge center. And we have 12 edge center, due to which we got 3 octahedral voids at edge center. And plus, we already have this octahedral voids at body center, due to which total number of octahedral voids in a cube is 4.
Okay. Yes.
Okay. So basically, if you are going to take the ratio tetrahedral is to octahedral, it will be 8:4. That will be equal to 2:1.
8:4. Yeah, 2:1. Okay.
Please do write it. In the next class, we are going to finish this chapter. I think we should do some questions.
Yeah.
Right?
Sure.
Please do let me know when you are done with this.
Yeah, 1 minute.
Yeah, take your time on this.
Yeah.
How's yours done?
Yeah.
How's your solution chapter?
Solution chapter. Yeah, good. Yeah.
Good. Okay. Are you good with concentration term, mole concept?
Am I good with
Concentration term, molarity, normality.
yeah, I had to revise that, but if I revise that, I will know that.
Okay. Before starting any chapter, I will tell you which chapter we are going to start, so that you will be able to revise and we will complete.
Yeah, sure.
How's your maths and physics?
Maths and physics, yeah, they little work. Yeah, I mean, maths is okay, but physics, yeah, I need little practice. Yeah.
Which is your favorite subject? Physics,
But
chemistry, maths. Which you are
uh,
in good?
yeah, I think chemistry. Yeah, I think.
Chemistry. Okay. And this is a scoring chapter for your
Yeah, for
entrance also.
JEE. Yeah.
Mm.
Wait, should I solve this?
Yes, yes. I just
Okay,
gave
okay,
you four.
okay, okay. Wait 1 minute. Is it 8?
Is it HCP? It is
Yeah.
octahedral.
Okay, okay.
No, 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 not tetrahedral. It is HCP and CCP. I wrote it. The nearest
Okay,
neighbor
okay.
in radius ratio. Where it is? Can you see it? They have, that is basically BCC8, octahedral 6. Can you
Oh,
see
okay,
the
okay.
CCP and HCP?
Yeah, yeah, okay, okay, yeah.
The
Okay,
questions are very easy on this.
yeah,
On this. Okay, wait a minute. I'm going to give you another question. Where
okay.
it is? Shit. The next topic is basically uh, your imperfection in solid. Are you aware of that?
No, 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 no,
Imperfection, like okay, okay. Good. Short key defect and
no.
Frankel defect. Okay, okay. In face centered cubic unit cell, not cubic unit cell, cubic lattice. A unit cell is shared equally by how many unit cells? Should I give option?
Wait, let me see. Yeah, options, okay.
Okay. Option A is basically 2, B is 4, C is 6, D is 8.
Is it 6? 6, right?
Yes, it is.
Uh,
It's very simple, right?
yeah, yeah, it's simple.
In face-centered cubic units lattice, a unit cell is shared equally by how many unit cells?
Yeah,
6. Yes, because we have like this structure and this. Okay.
yeah.
Now next. Wait a minute. Maybe we have done this question. So switching to the next question.
Okay.
Next question is lithium metal crystallizes in a body centered cubic crystal BCC
Yeah.
if the length of the side of unit cell of lithium is 351 picometer. Radius of atomic, radius of or atomic radius of lithium will be very simple. It is
Okay. Yeah, like 151.9 something, 98.
very good, very good. So the question on this in this chapter is very easy, basically.
Yes.
So wait a minute. Okay, the next question. The number of octahedral words per atom present in a cubic close packed structure is
Yeah, it's 4, right?
the number of octahedral words per atom present in a cubic close package CCP. We are talking about
Oh,
per atom.
okay, per atom. So what, 1?
Yes, it is one. So
Okay, okay.
beware of the terms like
Yeah.
total number of octahedral words is 4, but we are talking about per atom. Per atom it will be 1, right?
Okay, okay. Yes, yes.
Okay. Now let's start the imperfection. Imperfection in solids. So basically, what is imperfection? It's
Okay.
very simple. if you are going to buy anything,
Okay.
and there will be imperfection in your if you are going to buy a jeans, and how we are gonna recognize whether it is defective or perfect, that you can easily decide. But in solid there are imperfection that depends upon basically there is name, what is the type of imperfection, and everything. So basically these
Okay.
are of two types. Defects that we call defects are of two types. The first is basically point defect. Point defect, that is also known as atomic defect. That is also known as atomic defect.
Okay.
And the next one is electronic defect, which is very easy. Electronic defect, and that defect is basically unintentional. Like if you are going to dope, like have you studied semiconductor?
I mean, yeah, yeah, yeah,
You know semiconductor that partially conduct electricity or not conduct
yeah,
electricity, right? In
yes.
order to make a semiconductor conductor, we do doping. That means basically we know that how metal, why does metal conduct? Because it has free electron, right?
Free electron, yeah.
So basically in semiconductor we do a lot of things like doping. Doping is like we are going to mix it with another element that will
Okay.
help to conduct electricity.
Okay.
And in order, if you are going to do, that is we call it milawat, adding another thing, that is defect, right?
Yeah.
If something is pure and if you are going to add something, that will be defect. Yes or no?
Yes.
So that is basically electronic defect, and that is very easy. So we will focus first on point defect. Point defect, and this point defect is of basically three types. Three types. That
Okay.
is basically a stoichiometry, a stoichiometry defect, and then there comes impurity defect, and there comes non-stoichiometry defect. So please write it. Today we are going to only write the name, or on Wednesday we are going to complete this chapter. And since we have very less time, so I will suggest you to complete your concentration term, so that in on Wednesday we are going to complete concentration term also.
Okay. Okay. Yeah, done.
Done. Very good. Now see, this stoichiometry defect has four types. That is vacancy defect, then interstitial defect, and then short key defect, and then Frankel defect. Now, this non-stoichiometry defect is basically metal excess defect, and then metal deficiency defect. Basically, this will be further divided, that we will study. First, I am going to tell you about what is stoichiometry and what is non-stoichiometry. So basically, if
Okay.
there is an ionic compound, just suppose Na plus Cl minus. In a stoichiometric defect, if there will be any defect, that means addition or subtraction. If you are going to take out after defection, there is cation and anion ratio that will be constant. That will be constant before defect. Are you getting my point?
Yeah.
If the ratio
Yeah.
is 1:1 before defect, after defect the ratio will be 1:1. But in a stoichiometric defect, cation and anion ratio is not constant, that can be changed. This will
Okay.
not be cancelled. it might happen that cation will be greater than anion after defect, or cation will be lesser than anion. You can see metal excess defect, that means here metal is in excess. Metal
Yeah.
deficiency defect, that means here you can see metal, that means cation is in the metal here more, and here it is lesser.
Left. Okay. Yeah. Okay.
Okay. So, Davis, do you have any doubt?
Uh, no, no.
Just revise it, and okay, no problem. So I will see you in the next class, and you will get assignment too. I will send it to them, and
Yes.
I have sent two books to you, in which one is for NEET, which will be not that much easy, but it is good for men's also. You should do this also.
Okay.
And there is one IIT in Arihant,
Yes.
previous years. Both are previous years question. You can practice from there, and
Okay.
I'll see you on Wednesday. And please do the concentration down, the first 25% part of solution.
Yeah.
Okay.
Yeah.